Carbon economics, our vision to make economic modeling accessible to everyone. In evaluation of projects or future ventures, one would have to gather a multidisciplinary team of individuals with the expertise and experience required to design and evaluate the project and options. This would generally also involve building an economic model to assess the value of the project options. This would in turn require expert knowledge of modeling, an in-depth understanding of forecasting using drivers, activity-based costing, evaluation economic theory, and implementation of strict accounting and audit procedures. Spreadsheet-based models address the needs for budgeting, forecasting, planning, and optimization, but have inherent shortcomings such as auditability, multi-user capability, transparency of business logic, version control, what-if and scenario capability, and integration with source systems. Recent statistics have predicted that only 30% of models developed are successfully implemented as a sustainable business model. Faced with the reality of changing project assumptions, mine design, mining methods, and engineering assumptions, time that should be spent evaluating and running scenarios and options is rather spent updating and maintaining a spreadsheet-based model. The carbon economics solution puts business modeling in the hands of business and no longer requires the model builder to own, maintain, and run the model for the business. Object-oriented modeling with embedded modeling and business logic allows a business user to quickly configure a detailed activity-based model to represent the mining operation structure and all activities. Carbon economics follows the 6 pillars required for effective model design and building. Define the problem that must be modeled. Create the modeling logic building blocks required. Assemble the model structure from the standard building blocks. Generate scenarios and test options. Analyze the results per options and scenario. And communicate results to all stakeholders. And, as will become clear during the course of this demonstration, carbon economics excels in all areas. Defining the problem. Carbon economics allows for top-down and bottom-up modeling. In other words, models can be built at a high level and broken down into more detail as information becomes available. This means that a high-level model can be configured at the start of the project to evaluate the project. This would initially have a low level of confidence in project assumptions, but carbon economics would allow the project team to focus on the main drivers of value to achieve the desired project outcome, while continually updating the model assumptions as more information is finalized, and thereby increasing the level of confidence in the output numbers. True value engineering now becomes a reality. Create building blocks. Mining entities such as half-levels, levels, shafts, and mines are all defined to represent the mining structure. These standard blocks contain all the business logic and are defined as templates which will be used to assemble and complete model structure. Labor designations are grouped into team definitions, which will then be assigned to the relevant activities. The standard resources applicable to the business are defined. These will also be assigned to activities. These resources can be broken down into detail to reflect the business's budget line items, making budgeting a standard feature in carbon economics. Assemble model. The business user now uses the standard templates that have been defined for mining entities, activities, resources, and resource elements to define the overall mining structure and activities. The user enters business rules to each team and resource and assigns a cost driver for forecasting purposes. Simple and configurable data adapters allows for integration with external data sources and the automatic instantiation of the model structure. For example, this allows the model hierarchy and activity structure to build dynamically from the mine plan or SAP database. An important concept of object-oriented modeling is that any changes to model logic and business rules in the templates will automatically be replicated to all instances. This we refer to as inheritance. Generate scenarios. Once the model has been assembled, a user can now generate scenarios. Data adapters allow integration with external structured data sources such as SQL and even unstructured data in Excel. Actuals can be imported daily for actual versus budget comparisons. The detailed production schedule can be imported from the mine planning system or the Carbon-14 mine scheduler, and the full labor plan and cost budget and forecast calculated. Any number of production schedules can be costed in this way at the push of a button to compare costs and NPV. Dynamic budgeting is now possible if the production schedule is updated monthly. What if and scenario capability via datasets allows management to generate multiple budgets and forecasts to test different assumptions and strategies. Advanced analytical functionality allows for path of greatest variance analysis to understand the reasoning for variance between budget and actual using reverse modeling techniques. Value driver trees, attribute analysis, and waterfall charts allows for rapid dissection and evaluation of your model. Waterfall charts are especially useful for quantifying cost contribution and drilling down to individual costs. User configurable management dashboards allow for what-if levers to be adjusted, testing changes in the external environment such as electricity cost escalation or changes in labor rates going forward. The value driver tree allows one to visually dissect the model, rapidly identifying root causes of variance between budget and actual. Any reporting requirements can be configured based on specific business needs, such as income statement, balance sheet, or strategic planning report. The application includes a reporting database that allows reports to be generated in Microsoft reporting services, business objects, Excel pivot reports, or other reporting environments. The slides component allows the business user to generate their own evaluation reporting slides that are linked in real time to the model. This is great for presentation purposes where the user can make changes to the model on the fly and graphs and results tables are updated immediately. In summary, Carbon Economics offers rules-based labor and cost budgeting, the ability to configure any mine hierarchy and activity structure using standard objects and templates with business and modeling logic via intuitive user interfaces. Simple and configurable data adapters allows for integration with external data sources and the automatic instantiation of the model structure. Standard integration with the Carbon-14 mine scheduler and the ability to integrate with most other mine planning systems. No formula and logic errors, as this is predefined in all objects and templates and can be managed at the template level. The level of detail can be adjusted as required down to a bill of materials for budgeting if required. What-if and scenario capability via datasets allows management to generate multiple budgets and forecasts to test different assumptions and strategies. User configurable management dashboards allow for what-if levers to be adjusted. Advanced analytical functionality allowing for path of greatest variance analysis. And dynamic custom configurable reporting. Carbon Economics has been developed to address the needs of proper budgeting and forecasting based on the actual production plan. Once set up, the production plan can be imported at the push of a button, allowing for dynamic or rolling budgeting going forward. For more information, please contact Cyest Analytics.